Hey everyone, and welcome to Cutting Edge AI, Deep Reinforcement Learning in Python. This is technically Deep Learning in Python Part 11, and my third reinforcement learning course, which is super awesome. Deep reinforcement learning is actually the combination of two topics, reinforcement learning and deep learning. While both of these have been around for quite some time, it's only been recently that deep learning has really taken off, and along with it, reinforcement learning. The maturation of deep learning has propelled advances in reinforcement learning, which has been around since the 1980s, although some aspects of it, such as the Bellman equation, have been around for much longer. Recently, these advances have allowed us to showcase just how powerful reinforcement learning can be. We've seen how AlphaZero can master the game of Go using only self-play, playing against itself. This is just a few years after the original AlphaGo, which already beat a world champion in Go. We've seen agents learn how to walk and even recover after being kicked over, where they trained using simulation. Simulation is important because it doesn't require actual hardware, which is expensive, and if your agent, say, falls down, no real damage is done. We've seen agents learn hand dexterity, which is no small feat. Walking is one thing, but those are coarse movements. Hand dexterity is complex. You have many degrees of freedom, and many of the forces involved are extremely subtle. Imagine using your foot to do something you would usually do with your hand, and you immediately understand why this will be difficult. Last but not least, video games. Just this past year, we've seen some amazing developments. AIs are now beating professional players in CSGO and Dota 2. Simply put, if you want to be serious about AI, you want to study reinforcement learning. As I mentioned earlier, this is my third reinforcement learning course. So what makes this course different from the others? Well, essentially, each course gets more and more advanced as you go through the series. The first reinforcement learning course was all about the basics. The second reinforcement learning course taught you more about the basics, but also some of the groundbreaking work that allowed reinforcement learning to be combined with deep learning. This course gets even more advanced. Now that we know deep learning works with reinforcement learning, how do we improve these algorithms? This course is going to show you a few different ways, including the powerful A2C algorithm, the DDPG algorithm, and evolution strategies. Evolution strategies is a very interesting, new and fresh take on reinforcement learning that kind of throws away all the old theory in favor of a more black box approach, inspired by biological evolution. What's also great about this course is the variety of environments we get to look at. First, we're going to look at the classic Atari environments. These are important because they show that reinforcement learning agents can learn based on images alone. Second, we're going to look at Majoko, which is a physics simulator. This is the first step to building a robot that can navigate the real world and understand physics. We first have to show it can work with simulated physics. Finally, we're going to look at Flappy Bird, everyone's favorite mobile game from just a few years ago. Thanks for listening, and I'll see you in the next lecture.